In this video tutorial, we're looking at the distance formula and specifically trying to find the distance between 2 points, x1, y1, x2, y2. And the formula is derived from Pythagorean theorem. So if I have 2 points on the coordinate plane, x1, y1, and x2, y2, and I superimpose a right triangle here, we know in the Pythagorean theorem that a squared plus b squared equals c squared. So in this case, the distance for a would be the difference of the x values, and the distance for b would be the difference of the y values. So if I substitute those expressions in for a and b, and then I replace c with d, meaning distance, that's the variable we use in our formula, by taking the square root of both sides, I get d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's take a look at example 1. Find the distance between 2, -2 and -4, 6. So I'm going to rewrite my distance formula. I'm going to show the variables for the coordinates x1, y1, x2, y2. I'll graph it over here so you can have a visual idea. And then substitute the variables here. Be really careful about your signs here. And then if you get a negative variable, I would use parentheses when substituting. So combine your terms here, square them, add them together, and we get the square root of 100, which is 10 units. So the distance between these 2 points is 10 units. Here you can see the right triangle that we can make with this. And -6 and 8 are the distances of the legs of the triangle. Okay, the shortest distance between a point and a line is the perpendicular segment in between them. So I have 4 or 5 different points here, and you can see that the shortest one is segment AD because it forms a right triangle with the line. So we're going to use this idea to determine the shortest distance between point 1,5 and the line y equals 1/3 x minus 2. So I'm going to plot the point, and I'm going to graph the line, and this is already in slope-intercept form, y equals mx plus b. So I'm going to plot my b, which is -2, and then I'm going up 1/3 on my slope, and I graph my line. Now the slope is 1/3 here, so that means the perpendicular slope needs to be negative and reciprocal of this. So that would be -3/1. So if I go from 1,5 and go down 3/1, down 3/1, I run back into the line at point 3, -1. So here are my 2 points, 1,5 and 3, -1. And I use this in my distance formula now to find the distance between that point and the line, the shortest distance. So substitute my values here. And it's not going to be a perfect square in this case. So I'm just going to round to the nearest hundredth. So the square root of 40 is 6.32 units. So that's the distance between the point and the line. Okay, so now I have 2 lines, and I want to find the distance in between them. Well, x equals 3 and x equals -5 are both vertical lines, so this is an easy problem, and we've done these before. I could just count the number of units perpendicularly between the 2 lines, and it's 8. But we could still, if we wanted, to put this in our distance formula just as an exercise to make sure it works. And we see here that we get 8 units when we put this in the distance formula. You don't need to do this for vertical or horizontal lines, but it's a good check. So now we have two more lines, and they're not vertical or horizontal, they're diagonal. So we have to do a little bit more work than in the last example. We need to graph both of these lines using the y-intercept and slope. And now we can choose any point on one of the lines, and then from that point use the negative reciprocal slope, which in this case is going to be -1/2, and run from that point until we get to a point on the other line. And that gives us 2 points. So I'm going to go from -2, 0, down 1 over 2, and then I'll find my new point, which will be 0, -1. Now I could have done multiple other points, but I'm trying to find a point that had one of the coordinates is 0. It just helps simplify the calculation a little bit more. So be careful when substituting this into the distance formula. Keep your x's and y's together, watch your signs, and we are rounding to the nearest hundredth, so I get 2.24 units. So some other examples of points we could have used. I'm going to show you a couple right up here. 0, 4, 2, 3, 2, 8, and 4, 7. Those would also give us the same answer because that distance is the same. Okay, find the distance between these two parallel lines below. So this is the same problem. This time the lines are graphed for you. So we need to determine what the perpendicular slopes of the line is, which is 3 in this case. And then we're going to choose a point, graph the perpendicular line to find the second point, and then use the distance formula to find the distance. And there are infinite numbers of points to use for this to find the distance between the two. Again, I prefer to try to find one that has a 0 if I can for one of the coordinates, just to simplify the calculation. Okay, example 6, find the equation of the perpendicular bisector of the line between -1, 8 and 5, 2. Alright, so a perpendicular bisector goes through the midpoint at a 90-degree angle. So plot the points and draw the segment and find the midpoint. You could do this visually or use the midpoint formula, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So our midpoint is 2, 5. Now find the perpendicular slope to this segment. The slope of this segment is -1. So the negative reciprocal would be +1 over 1. So I'm going to graph the line and then determine where the line crosses the y-axis, and that would be our y-intercept b. In this case, it's 3. So now I can write the equation in slope-intercept form, which is y equals mx plus b, and that will give me y equals 1x plus 3. So that is the equation of the perpendicular bisector of that segment. Example 7, the perpendicular bisector AB has the equation -1/3 x plus 1. If A is -1, 8, what are the coordinates of B? So I'm going to graph the line and plot the point. Now this is one end of a segment. We need to find the other end of the segment by first graphing the line, which would be perpendicular to the perpendicular bisector. Then we have to see how many units down and over we go from A until we hit M. We'll call this M, the place where it crosses the perpendicular bisector. And in this case, we go down 6, left 2. And then we repeat from M until we hit the line again, down 6, left 2. And we get -5, -4. So this would be the other endpoint. It's equidistant from M as A is from M, and that's B. All right, try the practice set.